252 million years ago, Earth came closer to losing life entirely than at any other point in its history. Long before the first dinosaurs took their first steps, before birds filled the skies, before mammals appeared on the plains, the planet was ruled by strange creatures and teeming oceans. Yet, in a geological instant, almost everything was gone. This catastrophe is known as the Permian Extinction, or more grimly, the Great Dying. It erased over 90% of life in the oceans and 70% of life on land. To picture this event is to imagine a planet nearly silenced, where the chorus of life fell quiet and the land itself seemed abandoned. No extinction before or since has ever matched its scale. It was a moment when Earth itself became hostile and survival seemed almost impossible. Before disaster struck, the Permian world was thriving. At this time, the land was united into one massive supercontinent called Pangaea. It stretched from pole to pole, its vast deserts and forests covering an area so immense that climates were extreme. In the interior, seasons swung between scorching summers and freezing winters, while the coasts supported lush wetlands and forests. Life had flourished in this environment. Herds of dicynodonts, stout-bodied plant-eaters with tusks and beak-like mouths, grazed across plains. Dimetrodon, with its great sail rising from its back, was an apex predator in swampy lowlands. Forests of towering conifers, seed ferns, and strange spore-bearing plants shaded the land. Insects buzzed in massive numbers, some growing to enormous sizes. The oceans, which covered most of the planet, were equally rich. Trilobites, ammonoids, brachiopods, and armored fish filled the seas, while coral reefs stretched for miles, hosting ecosystems as diverse as modern reefs today. For hundreds of millions of years, life had built itself into a complex, interconnected web. Few could have imagined how swiftly it would all unravel. The beginning of the end came from deep within the Earth. In what is now Siberia, a cataclysmic volcanic event erupted on a scale beyond human comprehension. For nearly 1 million years, rivers of lava poured from fissures, blanketing millions of square kilometers in molten rock. The Siberian Traps, as we call them now, remain one of the largest volcanic provinces ever to scar the planet. These eruptions belched colossal amounts of carbon dioxide, sulfur dioxide, and methane into the atmosphere. The skies darkened with ash, blocking the sun and altering rainfall patterns. Acid rain fell across forests, stripping leaves from trees and leaching nutrients from soil. Rivers turned acidic, killing fish and amphibians. At the same time, greenhouse gases trapped heat, warming the planet dramatically. Oceans absorbed vast amounts of carbon, making them warmer and more acidic. The balance of oxygen in the seas faltered. Currents stalled, and once thriving waters became suffocating dead zones. As the environment spiraled, waves of extinction followed. Coral reefs, which had flourished for hundreds of millions of years, collapsed entirely. Trilobites, survivors of countless earlier crises, vanished forever. Many groups of brachiopods and ammonoids declined to near extinction. In the oceans, vast swaths of marine life perished as oxygen levels plummeted. On land, forests withered and deserts spread. The lush ecosystems that had supported giant amphibians and reptilian predators crumbled. Without plants, herbivores starved. Without herbivores, predators died as well. Dimetrodon, once the terror of swamps, disappeared. Even hardy insect groups, usually survivors of upheaval, saw entire lineages wiped away. Fossil evidence from this time shows a striking pattern. Layers of rock suddenly devoid of the once abundant signs of life, replaced with silence. The mechanisms of this collapse were complex and interwoven. The heat from volcanic gases drove global temperatures to extremes. Ocean acidification dissolved shells and skeletons of marine organisms. Hydrogen sulfide, a toxic gas, may have bubbled up from stagnant seas, poisoning coastal regions. Methane released from thawing seafloor deposits may have triggered even faster warming, creating a runaway greenhouse effect. The Earth became a hostile, almost alien planet. Average temperatures soared. Rainfall patterns broke down. Winds carried toxic dust across continents. For creatures adapted to stability, the changes came too quickly and too violently to survive. In this apocalyptic setting, survival became a matter of chance and adaptation. Burrowing animals had an advantage, hiding beneath soil and escaping the worst heat and toxic air. Small reptiles that required fewer resources endured where giants could not. In the ocean, some shellfish and fish clung to life in isolated refuges. These survivors became the ancestors of entirely new waves of evolution. From the remnants of Dimetrodons came lineages that would give rise to mammals. Early archosaurs, ancestors of crocodiles, pterosaurs, and dinosaurs, weathered the storm. In the seas, a few hardy groups managed to hold on, eventually diversifying into the ancestors of modern fish and marine reptiles. But for a long time, Earth must have appeared barren, silent, and empty, its ecosystems stripped down to their simplest forms. The aftermath of the Great Dying reshaped the entire history of life. With so many species gone, the survivors found empty niches and new opportunities. Over millions of years, new lineages radiated outward, filling the spaces once dominated by others. The Triassic period, which followed, became the birthplace of dinosaurs, pterosaurs, and eventually mammals. Evolution had been reset, and with it, the stage was cleared for the great dramas of the Mesozoic. But this rebirth did not erase the trauma of what came before. The scars of the Permian Extinction remain in the fossil record, in the vanished lineages, and in the geological signatures of poisoned seas and scorched skies. Reflecting on this event today forces us to confront difficult truths. The Great Dying was not caused by an asteroid or a single sudden blow, but by long compounding shifts in climate, atmosphere, and ecosystems. It was the result of carbon pouring into the sky, oceans warming and losing oxygen, and a planet pushed beyond the limits of balance. It reminds us that life, no matter how strong it seems, is fragile in the face of planetary upheaval. Without that extinction, the world would be unrecognizable to us today. Dinosaurs may never have ruled. Mammals may never have risen. Humans may never have existed. Our very presence is tied to the survival of the few creatures that scraped through the Great Dying. The story of the Permian Extinction is more than history. It is a warning. It shows us that climate shifts and ecological collapse can reshape life in ways that no species can resist. It reveals that even the mightiest and most resilient creatures can vanish when Earth's systems spiral out of control. Yet it also carries a message of resilience. Life endured. Against impossible odds, it clawed back from near obliteration, reweaving the fabric of ecosystems and evolving into new forms. The world we know is the result of that perseverance. To understand the Great Dying is to understand both the fragility and the resilience of life on Earth. Stay curious, because our planet's past holds lessons for our future. The Great Dying shows us how close life can come to ending and how vital it is to protect the balance that sustains us. In the silence of vanished species and the fossils buried in stone, there is a message for today. We are stewards of a fragile planet, one that has endured catastrophe before, and one that still holds the power to recover, if only we give it the chance.